Let's go back to the populate model function we looked at earlier in this section. That method saves a ton of boilerplate code for us. In a traditional or legacy CFML app, if we had a form with, let's say, 10 elements, and we wanted all 10 elements to be saved into a SQL query, that'd be at least 10 lines of code, just for that one insert. Multiply that by all the other places in the app that use that form, or update that same database table, and multiply that by however many database tables are in your system, we end up with a lot of boilerplate code. And you know what? We haven't even gotten to the validation part of anything yet. So the 10 lines of boilerplate code I just mentioned is probably a lot more, actually. So populate model is saving us the lines of code that copy form elements into our component, but we still have to solve the problem of validating our user data. We could do basic things on the client side, like using HTML attributes and JavaScript to mark fields as required, or note things as this is an email address or this is numeric. But client-side validation is just for giving legit users a nicer user experience. All of that JavaScript can be disabled really easily, so it doesn't actually prevent hackers from breaking into the system. We need to use server-side validation to prevent that. So again, we're back to needing to write lots of repetitive boilerplate lines of code in our app. This was true with our legacy CFML apps, but in addition to populate model, Coldbox has a method called validate model that does just what our title implies. It validates the data. And it does so on the server side, making it a better defense against hackers than any JavaScript is ever going to be for us. Validate model isn't in the Coldbox core. It comes to us from a module called CB validation. I've already installed this, but if you'd like to install it on your machine, simply type the command on the screen, install CB validation, wait a few seconds, restart your app, and you're done. It's now installed. You can't just call validate model because Coldbox doesn't know how to validate your model. You need to tell Coldbox which fields are required, which are optional, if there are any size or length restrictions on the data, and so on. But with CB validation, that's super easy to do. Inside each of the CFCs that you want to validate, you make a constraint structure that looks kind of like the thing you see on the screen here. The keys are the names of the properties in the CFC that you want to validate, and the values in that struct are the different flags and metadata that describe how you're validating it, which fields are required, which are numeric data, and so on. So you put the constraint structure in your CFC, and that by itself won't do anything. We can take a look at one here, though. I've got my user CFC, and it's got all the properties in it that we had earlier, first name, last name, and so on. Right below that on line 9 through 16, you can see I have this .constraints, and in this case, I've got constraints on two fields, first name and last name. So the other three properties in our file, we're not doing any server-side validation on right now. But you can see I have metadata in here describing first name as required, that's set to true, and last name is also set to required. So you can tell just at a quick glance what kind of constraints we're going to be applying to our system. Just adding this constraints struct into your CFC won't do anything by itself. That's just setting up the CFC so that it can be validated by RCB validation later. But back in our handlers or services, wherever you call populate model, you've got an instance of the CFC, right? So after you call populate model, call validate model to check the data before saving it to the database. So validate model gives you the validate results object. First, if any data was found not to be valid, the has errors method in there will return true. So you'll know there's an error to deal with. And if that happens, you can call the get all errors method, which returns an array of, as you guessed it, the errors that are found on that CFC, or the data that's inside it rather. If has errors is false, then there's no errors, everything is fine, and you can save your data to the database as expected. Let's go back to the situation where there are errors for a second. We call get all errors and get an array back. So now you can see the relocate call. I'm just reloading the user details page, and I'm using the persist struct argument to send a copy of that errors array back to the RC scope so I can draw the errors on the screen and tell the user what happened. Over here in our views, we'll look up users, details, and there's the struct at the top of the screen. Just we have a little if statement here checking to see what's going on. Let's look at running this code in the web browser to see what happens when all these pieces come together. All right, so here's our app, and I'm just going to go to the add new user form. There's the same details form we've been using. Everything is blank, of course, because it's not a new record, or it is a brand new record rather that has not been saved yet to the database. And here's our details form. Same form as we had previously. There's the if statement we looked at just a minute ago with our catch to see if we got any errors back from the handler. Here's the save method in our handler again. You can see we're calling populate model. And if you remember from the previous video, I'm not actually passing in any other attribute here to tell populate model what data is going into the user's object. If you don't do that, by default, it will look in the RC scope. So I'm saving us a bit of typing by just using the RC scope here as the default. That gives us a fully populated user object. Then I'm calling validate model, which will go into our user model object. It will look at this constraint struct, determine that the first and last name are both required. If I leave those fields blank, validate results will come back with errors. So my has errors value will be true. It will go ahead and run this code in here, which gets all my errors back, saves them into an array. And then I simply bounce the user back to the details page with that errors array added into the RC scope so that it's visible for this if statement here that we have running in our app. Go back to the browser, save and reload that page just to make sure it's all fresh. And when I hit save, you can see last name and first name are both listed as required fields. We got server-side validation added into our app automatically simply by adding this constraint struct to our model CFC and installing the CB validation module. I didn't have to write any JavaScript. I didn't have to write any big if statements in my handler to check the required fields on the way in or anything else like that. And the nice thing about this is, let's say I have 5 or 6 different places in my app where a new user can get saved into the system. They will all pick up this constraints struct and have it available. And all you have to do in those 5 or 6 different spots in your handlers is call validate model. So you simply have one line of code to call to check an entire CFC to make sure that all the required fields are properly validated before saving things into the system. One other thing we did differently in this version of the app than previous versions, so our user CFC model is pretty small now. It's only got the properties in it and a constructor and our constraint struct in the middle there. All of the actual functions for saving and deleting users from the system have been moved out of there, and they're now placed in a user service CFC. This is just a different OO design. Some people prefer doing it this way, having a service layer do all of the big heavy lifting and having small models of just data or mostly just data. Some people put everything all together. You'll find different object-oriented designs have different pros and cons. I just wanted to mix it up a little bit in this demo to show you another way to architect your app if one of these might fit your workflow a little bit better than the other one does. So here's our user service, and it's got the exact same SQL queries in it that we had previously. There are a couple of small changes I've made though. For instance, save user, instead of taking the individual parameters on the way in, first name, last name, email, and password, it actually takes a user model object in now as the property. And it will dip into that model object to get to any of the properties that it needs for inserting and updating the data. Again, just a different design. This is a little bit more of an OO-centric way to go about doing things. So back here in our handler, you can see that when I do save the user object into the system that we got populated here on line 37, instead of doing get instance users like we did previously, I'm doing a get instance of the user service CFC, and then I'm having that call save user on the user object. So just want to make sure that you're aware of this is a little bit of a different design. User service CFC also lives in the models folder, just like my users item does. Therefore, I can call get instance on either the user's model or on the user's service CFC. They'll both be created for us by the get instance call from Wirebox because they both live in the models folder. And that's how our code works. You can see it runs just how we expect it to here. I'm going to go back to my list page and I'll change John's name to Jake just to show you that the system does in fact still work as we expect it to. And it does. There's Jake Lennon in our database. So now with just using the methods populate model and validate model, we're able to get all the boring boilerplate for saving form data down to basically 2 lines of code in our app. And the tiny bit of extra typing we do in the CFCs themselves for those constraints are okay because they're in the CFC. So the CFC itself is more self-documenting than it would be if it were in a legacy CFML app. We've saved a ton of time, cut down on the repetitive work, and made our CFCs more self-documented in the process too. That's quite an improvement over our legacy CFML development would have been. You can read more about using populate model at coldbox.ortusbooks.com, and you can read more about validate model and the rest of CB validation at forgebox.io.